Rectangle? What? Where else? Database management system? Too much jump. So you are in, what's your major? It's a computer science, right? In computer science or computer engineering, what's the main thing you are thinking you are dealing with? The computer. Oh. Computer. Okay. So, actually, what's the computer? Ever think about what's a computer?
Machine.
It's a machine, but it's different from the other machine like the vehicle or something camcorder. What's a computer? Have you ever think about what's a computer? It's a machine for computation, right?
Yeah.
I think the first, the grandparent and grandparent and grandparent of computer is, it's not ENIAC. ENIAC is a little bit young. It's even the Leibniz, it's a mathematician, also the philosopher. He developed something automatic computational machine. Okay, so it's a computer. So, but modernized, the contemporary computer has what? CPU, central processing unit, and also memory and hard disk drive to keep the data and information. So memory will be useful as a cache to what? Bridge the gap speed between the CPU and hard disk drive. Usually hard disk drive is much slower than the computational speed on CPU, right? So that is the general computer. Then I have another rectangle, this one. Then what is this? Program? Program? Motherboard? Motherboard is a part of computer, right? So that connect many of the device as a board, right? Then what can be this one? It's an operating system, good boy. Then what is the main purpose of the operating system? Because you should pass to get the degree, right? That's the important one. So why the operating system is one of the core courses in computer science?
Connect with the machine and the human?
Connect. I'm not connected with the machine.
How
Communication?
Yeah.
So without operating system, actually this big rectangle is nothing but the matter or the dummy machine, right?
Yes.
So to utilize the resource, computational resource or storage resource, any computer resource power, to use that we need operating system. What is actually the operating system?
Software.
It's a software, right? Correct. It's a group of software. It's not only just the software like the MS Word or other. It's a bunch of software. For what? To utilize computer resource power also to whom? It's a form human being, right? It's kind of in between human and computer. It's kind of interface. Can be used for the communication. So through operating system, you can order, you can ask something very complicated, the computation to the computer. The reason I'm going back to the basic of computer science is I totally shocked from your midterm exam. Okay? So I believed when you see your laptop screen, I believed you are searching the course related work and you are doing some additional work to improve your knowledge in the database, but the result of your midterm is, as you received from my email, it's one of the worst the semester in my teaching life. So I decided to go back to the basic of the computer before you understand the database. Okay? I believe yourself because you are a graduate student. Some of them are the undergraduate student, but almost graduate, like the junior or senior. So this is not the elementary school, this is not high school, this is not the middle school, this is a college level. Even the graduate, some of you guys are the PhD student. I believe you can manage the rest of the semester, even though we have the 5 or 6 weeks, but I believe. Okay? So this is the operating system. Without operating system, you cannot utilize the computing power. Then we have one more. The rectangle. What is this? Finally, is the application program. So especially in my class, this is the database management system. So computer. This is a computer. Sometimes it's called a server. This is operating system. This is the DBMS. So you know where DBMS is located. DBMS is not the computer itself. DBMS is not the system programming. DBMS is nothing but the application program. For what?
For management of database.
What? What is the main purpose of the DBMS? So without DBMS, is there any problem?
No.
All of you guys are not using any DBMS on your laptop, on your desktop computer. I never seen any student or personal individual who are using the DBMS system to manage the list of friends. Right? Nobody use. Then why we are learning? Why we are spending so many hours in this class to learn the DBMS?
To manage
To manage huge data, very large data, especially the very large data. Then we have very large data, so DBMS solved all the problem. Then why do you need to take this course? You can just purchase the DBMS, then use it. You need to design a model that follow the concept of the DBMS. For example, if you are using the relational DBMS, there are concepts to organize the very large data. Because it's a very large data, very hard to manage. Okay? Should be organized. In other words, you should use the data structure, specialize the data structure to organize, manage such a data. Especially in this class, we use the relational database model. Okay? Then we can manage and organize such a very large data. For what? Because it's very expensive data, so just keep, just like the jewelry or the luxurious car, just keep it. For using, especially efficient accessing the data. Okay, that is the main purpose. So for example, when we have the 10,000 students in the school, it's very hard to identify each one of you. Sometimes we can use the student identification number. Then I just call the student ID. Then I can easily find the student or search the student. Or sometimes if you have a very large database for the GIS, geographical locational information, at that time you can use longitude and latitude coordinate value to find the specific location. Similarly, in the relational database, it provides something way to find the data very fast. But before that, as we reviewed just before, this DBMS is additional software, application level software to manage the database. That without DBMS, definitely we can manage and handle the data. How can you handle the data without DBMS? For example, are you taking any programming language course?
Yes.
Which course are you taking right now? C++. For example, C++. In your C++ program, do you use a relational database model? No, you do not use. But do you have data in your C++ program?
Yes.
Definitely you have. So you define the variable integer I, then sometimes you store the data and assign the data or create the computer data and reassign the value. That is the way of data management. That's also data, but because that is quite small enough to fit where? Memory. It's a memory-based data management. So you can use memory-based data management, then access the data. However, when you have the very large, huge amount of the data, no, memory doesn't fit. It's not enough space to fit, for example, the 10 terabyte of the company data. So definitely it's not enough. Very slow. Even though you are using the virtual memory or secondary storage, it's very, very slow, or the sometimes forever time to search the specific information from your memory-based database or memory-based approach. So we need to use such an application program. However, to run such an application program, DBMS software, it requires a lot of research. Okay, you need to define some additional data structure, and for example, we learned the relational model, it's entity relationship model, and also it has the entity, the relation. Each relation has a primary key, certain constraint. Bunch of the algorithm and constraint are involved. That means to manage access the data is slower. So sometimes just using the program language is faster than the DBMS software. Then, how can we speed up to access the data using the relational database model? One simple approach is, what about computer? Think about the computer architecture. It's a cache approach. So we need something medium in between storage area, like the cache area. So in between the hard disk drive and CPU, we have memory. Even between the memory and CPU, we have L2 cache. Bunch of the cache area. So same thing in relational database model, we can utilize the cache area. In other words, memory area, to access very, very fast, okay, faster than without using DBMS. Actually, the using DBMS is slow, it's overhead. However, using the memory, we can speed up to access the data. So simple. Why don't we reuse the data? That is called buffer management. So buffer management is very, very critical in DBMS, database management system. So we call the hit ratio. Hit ratio means percentage of the data accessed in reused the memory, okay, not hard disk drive. So usually it is more than 70%, 97%. Higher than 97%, which means 97 out of 100 data will be retrieved from the memory, not hard disk drive. Actually, data are stored at the hard disk drive, but 97% of the data will be accessed in the memory. That is the reason we can speed up, very fastly access the data. This is the buffer management. Even buffer management is not enough to speed up. We already use the buffer management or cache or memory in the operating system level, even hardware level. Okay? There might be a limitation to reuse the access data. So another main approach to speed up access the data is, that is, indexing data structure. Okay? DBMS itself is the model that defines the data structure, how to organize, how to manage the data. So last class we discussed about the file structure used in DBMS system. So when you create the table, we can assign the file. It's not it's a similar as a general file structure used in operating system, but a little bit specialized for the database table. Okay, so that is the data structure. However, data structure is limited to access, even though that is ordered by the primary key. How long it takes to retrieve the data in terms of the computational complexity. If data is ordered, record is ordered, how long? So log n. Okay? So big log n. So big O notation in terms of big O notation is log n complexity. Okay? That's not enough. We need to little bit speed up more faster than that. Even sometimes data, if data is not ordered, which means so not primary key, I'd like to access the student data by major. Then what will be the fastest way? So just linear search, right? Because it's not ordered. There's no way to speed up. Just if you are lucky, you can get the data that you want first time. Otherwise, if you are not lucky, it will be the last one. So n over 2 complexity. When you have, it's a linear. Okay? When you have the 1 million of data, it's about 0.5 million average to access the data. So we need a new data structure to speed up the data. So why don't you borrow the idea of the index in your textbook? Okay? If you open your textbook, the index part, it has a bunch of list of keywords ordered by alphabet. So alphabetical order. Then next, there are page numbers. So you can easily search the keyword that you want, then find the page number, then look up. It doesn't take a time. It's exactly the same idea in the indexing data structure. So why don't we organize the data by certain keyword? Sometimes it can be primary key, not always a primary. It can be secondary key, not always a secondary key. It can be any attribute, can be ordered. It's separated from the file or table. So additionally, there is additional data structure. So exactly same format as the indexing in your textbook. It's ordered by certain attributes that include the primary key, secondary key, candidate key, any attribute can be used. Then what will be the page number? We cannot use the page number over here. There's no page index. So hash the different types of file. So in your textbook use page number and keyword. What about the indexing structure in DBMS?
Memory address?
It's an address. Address of what?
For
Record. It's the address of the record in the file. Then, can you remember that? When you create the table, it has a file, right? And that file consists of what? Block. So, block is the what? What is a block? I think I spent almost 10 minutes to explain about the block.
Fixed length of variable.
It's a fixed length for what? For record. Before that, communicate. In other words, it's a basic unit of I/O, input and output. In other words, when you want to read a certain data in the file or any data structure, it will be based on block. In other words, if you know the block ID, block number, in other words, block address, that is the fastest way. Shortest time, block ID. Using the block ID is the shortest time. So you can put the block ID, not the table name, not the file name, not the file ID, not the file structure. Only block ID is needed. Then you can For example, it's a block ID number 1. Number 2, so Lee is in block number 1. Then you can directly go to here, fastest way. So when you search, for example, select the name from student, for example, ID. Name is Lee. When you submit this one using SQL plus, so what is a SQL plus? Interface. You use the SQL plus, right, to complete your project. So what is a SQL plus?
It's interface.
It's an interface. It's a Oracle software program. For what? To connect the database and access the data, sometimes manage the database. It's an interface program. In your second project, you will implement kind of the SQL plus. SQL plus is what? The command line interface. You can type the command. Then whenever you enter, it will be submitted. So, for example, I'd like to submit this one. Let me put aside this part. I will explain later. So this is the SQL that you want to submit to the DBMS that you already created. Okay? So using SQL plus, what happens when you type and enter this one?
You will return a lot of data.
So SQL plus is nothing but the application interface program to submit this one to the server. Actually, this is where this program is installed. So your laptop or sometimes computer in the lab, not UB Oracle server. Okay? It's not the Oracle server, it's the client. That is called the client. Then client to the server, it is connected through the network. How do you know where the database is located? Can you remember that? When you log on to the Oracle database, you need what? Username and password. That is quite similar as other authentication systems. In addition to username and password, you server name. That is actually configuration file. Somebody already, me and IT service guy and Omar, already set up the configuration to log on to connect the server where the Oracle is installed. So, for example, you use ABUC, it's the name of our name. So, it's whatever, okay? ABUC in this file actually is set up the connection information. In this case, in our case, we use TCPIP network protocol. What is the TCPIP? Professor Lee is crazy. He is covering all the subject in computer science. Probably the final exam will ask this kind of thing. Explain about the overall the background of the DBMS. So, what is the TCPIP?
Control protocol.
I think many of you guys already took the network. 471, 571. It's a data structure, right? For what? For really, it's a data structure for communication to transfer the data, send and receive. So if we are using different the data structure, we cannot receive, we cannot send the data. That is called the protocol. Especially, we are using internet protocol, which is based on the TCP. Okay, that is the reason it's a TCP/IP protocol. Can you remember still the OSI 7 layer? So that will be the first the question in the final exam. Describe the OSI 7 layer. I forgot already. Right after the network exam. more than 10 years or 20 years ago. Okay, so that is the TCPIP. So this is based on the TCPIP. So according to the TCPIP protocol, what information do you need to make the connection? IP address or host name. Host name and IP address, what is the difference? For example, Jeongkyu Lee is kind of a host name, and my ID, the social security number, is kind of IP address, something like that. Okay? So what we need is actually IP address. So we need the IP address. In this configuration, ABUs, there is an IP address or host name of the server. In case of a host name, we need to check the DNS server. I think all of you guys know this one. So IP address. Then port number. According to the TCPIP protocol, like my house. My house has a lot of entrance, main entrance, front yard. And also we have another entrance, the backyard. We have the garage entrance. We have also garage door. Also, I can open the window for the living room and bunch of the door. So to access this house, there are a bunch of the door. That is the port. So we need to use the specific door, specific port number. So
1521.
Oracle use 1521. Must use only the 1521 port? No, if you want to change, so when you install Oracle database, you can change it if you want. At that time, client should follow that port number. For example, DB to use 50000 and 50001 port number. Informix user is a well-known port number. For example, HTTP use 80 port number, right? Do we need to use only the 80 when I install the web server? It can be changed. But 80 is well-known port number. So if you do not specify the port number, it will assign 80 as a default. It's the same idea. So 1521 is a well-known port for the Oracle DBMS. Each DBMS use their port number. Okay? So 1521. Is that all? You need username and password. For what? Anyway, DBMS is inside of the computer. Do I need some security check or login information to the server?
Yes.
But did you specify operating system username and password when you log on the Oracle database? Actually not.
No.
It depends on. Sometimes DBMS use directly their authentication for security. Sometimes DBMS use OS, operating system authentication. It doesn't matter. Might not matter. It will depend on how to set up the DBMS by the database administrator. So you have the username and password. Finally, you can access the database to submit this one. So when you submit this one to the here, what happened? No idea? We already connected by typing username and password. So there is a connection. Then I entered this one.
The DBMS will retrieve
First, who can understand this? Select name from. It's a language, database language, but it's a high-level language, which means because we are not very familiar with the machine, low-level languages. So this is kind of high-level language for human being. We need to parse. That's good. Actually, it should be compiled. Okay. So this one should be compiled. However, this how can you usually compile the program language? You code .c file, then run C compiler. Or .NET environment, you type the every source code or drag and drop, then debug. Right? What about this? When you enter, should be compiled, but you don't see anything. This kind of compiler is called what? Interpreter. This is called, it's kind of the compiler. It's the same as the compiler, but it's a command line by command line. One of the typical interpreter is DOS. Right? It's a command line by command line. So this one, SQL Plus use command line interface, so it's an interpreter. Whenever you type, it will be compiled. Compiler means it will be converted into something machine, the low-level language used in your database management system. So it's okay in terms of syntax. So it will be compiled. Then what will be the next step? We need to execute, but before you execute, you need to check whether you have, in terms of syntax, it's okay. However, do I have the student table? Do I have the name? Do I have something, permission to access this data? You need to check such a thing. Okay? So, I have the student, I have the name, the appropriate column, I have all the permission. Then, what will be the next step? We need to execute, but when we access the student table, there are a bunch of different ways. As I explained, I think the long time before I gave the example, when I go to the Manhattan, there are so many different ways. Okay? You need to find shortest time, or you need to find fastest time approach. It's the same thing. So DBMS need to check any permission. Next, DBMS find the best way. Otherwise, sometimes it will take 10 days. Okay? For example, when you have the 3 tables, it has more than 2,000 different ways to access the data. So among them, find one of them. Who is in charge of such a thing? Query optimizer. So maybe 2 weeks later, we will discuss about the query optimizer. So if you complete this step, that is called parsing. Even parsed information will be stored in the memory. For example, this is one menu, click. You have the 1 million of users who are using the same menu. The select from where? Select from student table where? So whenever your user, each user submit the same query, do we need to process the exactly same thing millions time? No, it's a waste of space, a waste of the resource. Instead, whenever this one is submitted again, it will be reused in the memory. Parse the information, also cache it. Okay? Then, this one is finally submitted. Find the best path. That will utilize the index. Finally, we go back to the main topic. Okay? Then, this is an index. How can you find the lead information using index? So, this name, first check whether Lee is indexed or not. If that is indexed, which means it's ordered by name. So you can find the Lee. How can you find the Lee? Binary search. This because it's ordered. So you can find the Lee, then it has the block number 10. Then go to the block number 10. In case of Oracle actually use not block number, even row ID number. Each row has their own row level row ID. That is the fastest way to find the data. Even block, one block, many data. So why don't we have the row ID? For each record has the ID, so Oracle uses such a row ID. So this is the block ID. Then 10, you can search the corresponding block ID 10, get the data. Okay, finally you find the data. Is that all? No, not yet, not done yet. What will be the next step? Where is it? Where are they? Memory? This is the first sequel, so this is in the hard disk drive file. So the first thing is you need to copy this information to the memory. First, copy. Actually, before that, before you search this data, you need to search the memory, whether there exists the cache data or not. Then, there's no read data, so we need to copy, then return data to the user. Okay? That is actually the overview of how database transaction is working based on the whole subject of computer science.
So next time I can store the data from the memory, right?
Next time, if you want, your friend submit the same query, then it will go to only the memory part, not goes to the real hard disk drive. Okay? That is the way of the two way to speed up the database access. One is buffer management. So buffer management is very, very important. So for database administrator, so set up the proper size of the memory area. That is the reason when you install. Is there anyone who installed the Oracle server for your practice or just for fun? If you try to install the Oracle server, it may ask sometimes a minimum 4 gig memory size or the minimum 2 gig memory size. That is the reason. Then, if somebody accesses the data, same data, it will retrieve the memory. Okay? So this is the overall thing. Then, I'd like to show, before we see the details of indexing structure, I'd like to show the one video. Actually, the last year spring, the 2012 spring, in the database, advanced database course, the student named me, at the time there were 8 students, developed the relational database system. So first, create the database. Then after create the database, so we decided using data specific, because sometimes we have many different databases, right? So using database, specify which database we are going to use. Then we can create the table by following the syntax of the SQL standard, like the SQL 92. At the time, we consider SQL 92. It's almost the same as the SQL syntax that we learned. It supports only the integer and string data types. Then we can insert the data. Unfortunately, at that time, we couldn't implement the index. Also, we could not implement the block-based approach. Instead, we use the file structure. Then it's a plain text file. Then insert the data. Okay? So insert. So as you can see, since we do not implement the primary, two values inserted, then we can select the data. We can get such a data. Okay? So same as the DBMS system that we learned. Truncate table means to delete all the data from the table. I'm not sure when I'm going to offer the continuing course of this one, because I need to implement the index structure that we are going to discuss today, also block-based approaches. So if you are interested in such a thing, maybe the spring 2012 at 14, table does not exist below the statement. It looks like the simple, but the implementation itself was not that simple. Okay? So we can drop the database. Okay? At the time, actually the most difficult part was the operating system concept. So the student study again the operating system a lot. Then we are going to move to the chapter 18, the indexing structure. So, first, single level indexing structure. Single level indexing structure is the same structure as the index in textbook. Okay, it has the index and the file. But for each index, it has the index item, key item that consists of the field value is a keyword in terms of the textbook index. Then pointer to record is a page number in terms of the index in the textbook. So this is the index key item, index entry. Any DBMS system use the same indexing structure as this one. Okay? There are two types of index. One is a dense index, another one is non-dense index. Dense index means all the value will be indexed. While non-dense, sparse index use only part of the value. What about the textbook? Textbook is a dense index or non-dense index? Non-dense index. If that is the dense index, I think the index part will be the same as or the bigger than the main part. So it's a non-dense. What about the primary key? Primary key should be dense index. All values should be indexed. Then you can search. If some of the index primary key is removed, I cannot find some data. Okay. Then, in the single level index, there are different types of index. One is a primary index, which means index for primary key. So, for example, this one. So, this is the block-based. Even index file is block-based. It consists of a bunch of blocks like this one. The primary key of this is the name. So it is ordered by the name along the blocks. Okay? Then first block has Aaron to Acosta. Second block has Adams to Acres. Then third one is Alexander to Allen. So on. Then this is the file. Okay? Data file, table. Then how can we make the index of this one? We can get the first data only, 1. We don't have to keep all the information in the block. Instead, we can get the 1 data, usually the first data of the block. That is called the anchor data, kind of representative data. The reason is that they are ordered. So we don't have to put the same block ID. Just get the first data, like the Aaron from the first one, Adams from the second one, and Alexander from the third one, and so on. That is the primary index. Then how can we search the data? So for example, I'd like to search the Angel Joe. Angel Joe is higher than Ellen. Yes, higher than Ellen and higher than Anders, Jake Anders, but less than Arnold. So Angel Joe belongs to this block. So we have the block ID hold to this one. Then you can find Angel Joe using binary search. At that time, somebody may be curious. Does it take a time to find the Angel Joe in the same block? What do you think? Do you need the additional time? Yes, we need the additional time in one block. But they can be ignored. Why?
Very fast.
Very fast? Why is it fast?
Because it's in memory.
Yes, it's in the memory. It's a one block. One block is the basic I/O unit. So it will be loaded into the memory. So in the memory, it can be ignored. So we don't have to worry about. But you should consider the complexity of this one. This one is also require binary search. One index to search the data is the binary search. Okay, then you can find the data. We can evaluate how fast is that. But I'm going to skip up. If you are interested in the indexing structure, you can, I think, definitely work by yourself. Everything is easy to understand. The main problem, the only concern is, so for example, using binary search, we need a 6-block access to access the data. Then we add one more block always. That is because to search the data, we are going to use index. So index total 6 blocks are needed. And finally, our goal is to access the data in data file. So we need always one more block access. Okay? So that is the reason. It's a 6 block, then one more block. The next single level index is a clustering index. Clustering index is sometimes we can make the index for grouping data. For example, the department number. So department number can be used for index. So in that case, so first data file organized by the department number 111, 222, 33, and so on. At that time, we can make the index by the department number, then block pointer. Sometimes it can be the same because so one block may have the several departments, but sometimes, for example, the 3 is 4, 5, 6 is scattered. So it's based on the department number. This is a clustering index. Another type of clustering index is, in this case, one block may have the different value, but if you do not allow such a thing, different value, it can be one, at least one, the value for each block, like this one. Secondary index is so far clustering index, primary index, they are sorted by the key, index key value, like this one, 111, 222, what the name is sorted by the key. However, sometimes you can make the index that is not sorted. For example, this one. So I'm going to make the index for secondary key, which is not ordered. For example, Social Security number is the key. For example, employee table. Employee table has the employee ID as the primary key, but it has the Social Security number as the secondary key. Okay, it's also unique key, but it's not primary key, but it's a candidate key. So at the time, some of the application would like to access the data, employee data, by using social security number, but that is not ordered. Can we make the index? Yes, we can make the index like the ordered by the secondary key, like this one, then point. Is this the dense index or non-dense index? It's a dense index. We need all the data. Before, the previous, this ordered data, we don't need all the data. It's a non-dense index. However, secondary index requires such a dense index. So you can evaluate how many access are needed to access the data. Always we need one more time access, log access. Okay. Why do we need to compute the number of block access to evaluate the index structure? The number of I/O is the most important part to decide the speed, because accessing hard disk drive, the data structure is the critical, the most